So, hello everyone, my name is Asad Mirza. I'm PhD candidate here in the BME department at FIU, and I'm going to do a series of MATLAB workshops for you. This is part one, Introduction to MATLAB. So this might seem a bit low level, but everybody has to start somewhere. So part one is just going to be intro. Part two, which is going to be 2 weeks from now, going to get more complicated, advanced plotting stuff. And then part three is going to cover even more advanced topics that you might need to use maybe when you're senior year or graduate school. So first off, what is MATLAB? So originally it was made by Cleve Muller at Stanford University in 1970. And the reasoning was he needed to figure out a numerical computational way to do complex linear algebra numerical analysis and optimization of equations, but there wasn't a way to do it that wasn't very difficult and involved a lot of punch cards. So he ended up working with some people to create MATLAB, which stands for Matrix Laboratory. So linear algebra and dealing with numbers is very heavy in MATLAB, as you can get from the name. So it's dynamically typed, meaning that as a programmer, you don't have to actually declare any variables. So if you're coming from Java, for example, or C, anytime you want to store some information, you have to tell the computer, set aside some memory and have it be this long and this much storage or whatever, and have it in reserve for this variable. And in MATLAB, you don't have to do that. You can just say A equals something, and MATLAB will take care of however much memory it needs to store that variable. You don't have to worry about that. So you just initialize, and that's it. And as the name would suggest, everything in MATLAB is a matrix. So if you have a single value, so like a number 1, 2, 3, 4, whatever, or even a single letter A, B, C, whatever, that's a 1 by 1 matrix. If it's a vector, so multiple values, that's a 1 by n or a n by 1 matrix. Usually the designation is row times column. So 1 row times n columns, or n rows times 1 column. And you can have a full-blown matrix that can hold multiple values. So you can have an n times m matrix. So some number of rows, some number of columns. And this can go on into the third, fourth, fifth, sixth dimension, however much you need to hold your data. So MATLAB is very fast at handling matrices, because it's optimized to do that. Hence, everything in MATLAB is a matrix. So you always have to think of whatever you're doing in MATLAB as being basis of matrices. So just to sort of spruce you guys and sort of invigorate you guys a little, what can MATLAB do? So you can do cell models in MATLAB. For example, here's one I developed for Dr. Sukias. And this is a model of a vascular endothelial cell where you can change various parameters and see how it affects voltage across time, concentrations. You can fill around with parameters and test out different things without having to actually spend money and do these expensive experiments. You can just test out on the model things that you might be interested in. And I believe this is actually available on his site if you take a look at it. So this is what I helped him develop for the BME 2740 course, which is an exponential simulation. So you can see how if you adjust the injection current, you pass the threshold needed for activation, and then you get the spiking cascade for action potentials, and you can change capacitance, conductance, and so on and so forth. And this is an educational tool that I hope he's using or still using. Hope he hasn't forgotten about it. Then you can also do bone modeling. So this is one thing I developed for Dr. Christie in his biomaterial course. Generalized Berger's model for the variable Kelvin, volt, Voigt, and Maxwell elements. Here's one for, I believe this was Dr. Hutchison. It was a heat transport thing. It wasn't this exact thing, but it was similar to it. And you can see heat transport occurring across time. Here's some kinesiology examples. So you can track person movement with vectors and track moments of inertia and centers of mass. And then here's what I did for my senior design project, where I designed a GUI entirely in MATLAB that controlled a motorized stage and cameras. So you can synchronize both of them and take images on the micron level. And that was very interesting and fun. And then here's another example of how you can use MATLAB. In this case, it's an in-processing example, where you can input images in MATLAB and then detect and track how much the image moves across time. And if you convert that to strain, you can recover the pulsicity of, in this case, a cardiomyocyte. And as a fun thing, you can also make Super Mario Brothers in MATLAB, and I have downloaded this, and it works. This is actually just a very elaborate plot. And you can theoretically make it after BME 2740 because it's just a bunch of plotting commands, refreshing the screen over and over again based off keyboard shortcuts, which is a game. So this was fun to run into. So let's go ahead and get started with MATLAB. First things first, the default color scheme in MATLAB burns my eyes. So I generally suggest to everybody go to Preferences, go down to Colors, and then adjust the colors here to make it green and black on the background so it's not too big on your eyes. You could also go down to Fonts and increase the font size so everything looks larger. And you can also play around with these other settings to customize them as you see fit. Now, when you open up MATLAB, generally this is what you should see. If you don't see this exact layout, go here to Layout and click Default, and it should format to this specific shape. So here's how everything looks like. In the very center, you have the command window. Think of the command window as a gigantic glorified calculator testing area. If you want to quickly test out a function, test out some small little bit of code, see how it works, see what output it gives you, plop it in the command window, see what the outputs are. Over here on the right side, this is the workspace. Now, the workspace is where you can hold all the variables that you're making and keep track of them. So you can see the name, the value, the size, how much bytes, so how much space is taking in memory, and it even tells you the class. So double generally is for storing numeric values. You char, which is for storing letters and words. And you have various other types of classes, but generally these two are the main ones you'll be dealing with. And then over here on the left side, you see here called the current folder. The current folder is basically what MATLAB is viewing as its world. Everything that you run on has to be inside this current folder. So anytime you open up an image, let's say, that the image has to be inside of this current folder, the main root of that folder. If it's not, MATLAB will say, where's the folder? I'm missing it. Where's this image? I'm missing it. If you click on some files, for example, this bird.jpg image, on the lower left hand, you see a pre-rendering of the image with some details on it. So for example, in this case, width times height. And it does similar things for other stuff. For example, if you click a text file or a map file, it gives you a preview of what's in the file, perhaps the size of the file, and little bits of extra information there. Then over here on the top, this ribbon tab here, you see some major things that you can select, but the top parts at the home, the plots and the apps. Plots is basically just an easy way to plot variables together. So if you have some variables in your workspace and you don't want to type some code, you can just click plot, and MATLAB will automatically suggest some plotting functions that you can use that it thinks you might want to use. And then over here on apps, MATLAB, because it's such a large company and people generally want to streamline the workflows, has a bunch of pre-built apps dedicated for specific applications. So for example, image analysis, signal processing, audio processing, neural networks, and so on and so forth. And over here, all the way on the right, you have the little documentation button, which is useful for finding any information you want on any functions and tools in MATLAB. So let me go ahead and switch over to MATLAB and show you some stuff. All right, so this is what I was saying. The workspace looks like this. Default. If it does not, if you click an image, it'll give you a preview on right here. Here's what I meant by plotting. You have various types of plots, and all of these are grayed out right now because I don't have any variables to plot, but here's you can see them all. And here's what I meant by all the apps. So for example, if you, for example, wanted to, what's a good one? Let's say curve fitting. Right click curve fitting, it'll open up the curve fitting toolbox for me. And you open it up here. So this is a nice little handy curve fitting toolbox. So if you had some X, Y data, for example, you can start fitting it using various types of equations, and this sort of streamlines the process for you. But you can do that for just about every single app here. Over here is the documentation I was talking about. So let's say, for example, you forgot how in the world sine works. Just type in sine, and it'll say, oh, do you mean sine in radians? Do you mean the sine fixed point values? Do you mean the symbolic version? Do you mean sine as degrees? And if you click it, it'll open up MATLAB documentation. And then it'll start giving you examples. Oh, so here's how you do sine degrees of 180. So 180 degrees, and it says it's 0. And it shows you that this is the same thing as doing sine of pi, which is 1.2 e to negative 16, so might as well be 0. Its computer's round a little, limited amount of memory. And it gives you examples and everything. So that's the major stuff here. And So this on the center is the giant calculator like I was talking about. So for example, 2 plus 2, you can certainly do. And the moment you type in something here, it shows up in your workspace. And as you can see here, right here, name, the value it has, the size of the matrix, and how much memory it's storing, and the class. So first off, arithmetic operators in MATLAB, you can do addition, subtraction, multiplication, right division, left division, exponentiation. And they're just as you would expect it. The plus symbol, the minus symbol, the star symbol, forward slash, backslash. And this caret symbol for exponentiation. And MATLAB takes the precedence of parentheses first, then exponentiation, then multiplication, division, depending on which order it comes first. And the last thing it'll do is addition and subtraction. In case you're wondering what the PEMDAS rule was for MATLAB. Now, next thing I want to, actually, might as well show it to you. Where is it? So just in the interest of saving time, I pre-wrote some of this. So clear CLC, close all. This gets rid of all the variables in your workspace. This cleans up your command window. This closes any figures you have. You can add comments in MATLAB by just doing the percentage symbol, or the hashtag as people call it nowadays. And then you have various kinds of arrays. So ways you can store values. You can do true for a logical statement. So if you highlight some code and click evaluate section, in this case, we have this thing called T. It has a value of 1 by 1 byte, because you only need a 1 byte to store a true or a false. And this is the class logical. And you can also do false. And like I said, you can also do char. So yeah, cat house. In this case, cat being 3 letters, it's a 1 by 3 matrix. House being 5 letters, 1 by 5 matrix. And like I said before, you have numeric stuff. For example, if you just do s equals some number, in this case pi, you see pi is being stored as 3.1416, so it's rounding a little, but it's 8 bytes. You can also store more things. So for example, r double, which is 35464. And here's a nice little hint. You can actually save things as something other than a double. The double is the default because usually you don't know how large of a number you're dealing with. So by default, MATLAB saves it as a double, which can hold a really large value. I forgot what the upper limit is, or a really small value as well. But if you know your number is restricted to certain ranges, you can do in16, which can save a number up to 2 to the 16, I believe. So if you do r16, in16 to r double, take a look here. R int holds 2 bytes versus r double holds 8 bytes, so you save some space there at a cost of rounding a little. Next thing, let me bring this up. Already talked about that. Matrices. So everything is a matrix in MATLAB. All operations are done in matrices. As I mentioned before, a single value is a scalar 1 by 1. You have a row vector, 1 row, 3 columns. Column vector, 3 rows, 1 column. You can have a simple one-dimensional matrix, that's 3 rows and 3 columns. You can do 2-dimensional matrices, so 3 rows by 5 columns, but then there's a third dimension to this, so it's 2 here, so 2-dimensional. You can also do 3-dimensional. And this can keep on going on and on and on. You can have multiple dimensions on your matrix. For example, standard images are 3-dimensional matrices, one for each color channel, for example. And here's how they look like. So you just save it as a single value. If you want to do a row vector, you can separate them with spaces or commas. So if we do x row, you can see here x row is 574, 1 by 3 matrix, 24 bytes. And if you want to do a column vector, you separate them by semicolons. So 3 rows, 1 column, same size as before. And if you want to swap rows and columns, you can use the apostrophe symbol. So for example, if I had x row, and I want to make this a column vector, because right now it's a row vector, I can do x row percentage, apostrophe symbol, and that turns it into a column. Straightforward. And if you want to have a 3 by 3 matrix, you do the spaces for the first row, and then the semicolon tells MATLAB go to the next row. and then you continue on, go to the next row, and this will give you a 3 by 3 matrix. Now, there are other ways you can generate a matrix in MATLAB. The general one of the quicker ways is you can do this array creation by doing the first term, the spacing, and the last term, and separate them with colons. So if you do 0, colon 1, colon 10, this will give you an array that goes from 0 to 10 with a spacing of 1. So if I run this little code, let's bring this up here. Run this again. So you can see here, C colon is now 0, 1, 2, 3, 4, 5 without having to type it. And this is really useful if you suddenly want to type or make a really long array, but you don't want to type all the numbers. Now you can also adjust the spacing to however you want. So now I want to start at 4, go to 16, spacing of 2. So 4, 6, 8, 10, so on and so forth. The other way you could do it is using this function called linspace. And the way linspace works is it takes in 3 arguments. So you give it the first term, the last term, and then number of elements. So in my case, I'm saying, okay, I want to start at 0, go to 100, give me 1,000 elements in between. And if I run this, it'll give me a single row vector that has 1,000 elements in it, as you can see here, that go from 0 to 100. I'm about to type all this out. Nobody will want to do that. And actually, if you ever forget how to use this, documentation, and it gives you a number of examples for it. Or you can just type in help in the name of the function, and then a compressed view of what's shown in the documentation will show up here. Now, how do you access values in a matrix? So the way you do it is you just call the name of the matrix, and then the value you put in here is the index of it. So X row has 3 elements in it, and they're always numbered starting from top left, going to the right, and then switching over to the next row. So X row of 1 will bring the first value. The second element would be X row of 2. And then the third would be 3. But if you try to go outside of it, so this has 3 elements, but if you try to access the 4th, you'll get an error. So if we do X row of 1, it gives me 5 as expected. 2 gives me 7. But if I try to do 4, this matrix only has 3 elements, so this will give me an index exceeds the number of array elements, because obviously it exceeds the number of array elements. Now, if you want to access every single element in a row, you can just use this colon symbol, and this just grabs everything in the matrix and just spits it out. If you just want the last value, you can use this end command here, and this just grabs the very last value. Now, if you want to start grabbing specific values, you can use this colon operator here. So let's say you only want the first 2 elements. Then you can just do X row 1 to 2. And let me bring back this matrix right here. So if we had the 3 by 3 matrix as well, and let's say we want to grab everything from the second and third row and the second and third column, we can do X row, X3 of 3. Remember, it's always row then columns. I want everything from the second to third row and the second to third column. So it should give me this small little subset of this matrix, and that's what it does. You can also say, okay, everything from the first column and the third column. So now this would be, remember, you have to specify the rows and then the columns. So if I want the first, if I want every single row, but only the first and last column, then I'll be every single row, but I only want the first and last column. So that's 1 and 3. And now it's 5, 6, 7, 56, 6, 86, which is the first and last column. Now, before I continue, any questions? Nothing? All right. Put this over here. All right. So continuing on, you can also do basic mathematical functions. So you have your sine, cosine, you have the inverse, a sine, a cosine, and such. You can do degrees by adding a d to all these. You can do complex variables using absolute value, conjugation, imaginary numbers. Exponentials are handled with exp for the Euler's number. Then you have log in MATLAB. Log just by itself has a base of e. If you want log 10, then you can do log with a base of 10, you can do log 10. If you want a base of 2, you can do log 2. If you want any other base, you can use the change of base formula. Just go find it on Google. It exists somewhere. And if you want to do square roots, you have the square root function. So then right here. So sine pi, really small number, cosine 0, 1, as expected from a unit circle. Sine d, so the sine of 180 degrees, because we use the d here, 0. Cosine d, 45 degrees, if you remember, that's square root of 2 over 2, or approximately 0.707. Exponentials, so the exponential of 1, so e to the first power, or just e, is 2.7183. Log of this should just give you 1, because remember, log is always base of e. So what's the log base e of e that those two functions cancel each other out? Should just get 1. Square root of 4 gives the principal root, so it only gives the positive, so that's just 4. It ignores the negative roots. Complex numbers, so if I do absolute value -5, it just returns 5. And you can also do things like the angle of 1 plus 1i, and this gives you 0.7854 as radians. And then you can multiply this by 180 over pi to turn from radians to degrees. And you get 45 degrees. Straightforward enough. Now we get to plotting. Any questions before I get to plotting?
It would help if you guys have MATLAB and can follow along as well. I find the practice very useful.
Definitely. Oh, someone's saying something? No. All right. So MATLAB, you generally want to use it to plot various things. So the basic way you can plot in MATLAB is x comma y. They have to be the same vectors in terms of the size. So the element numbers that they have to match. So for example, you can do x of this value, y of this value, and you can plot them. And by default, MATLAB just tries to connect each numeric indices with the next, with a straight line. So it's assuming they're in ascending order, which they might not necessarily be. You can also change the line styles by doing x comma y comma and in quotes whatever the line operator is. So for example, if you do x comma y and then you put in a little apostrophe symbol and you do dash dash, that gives you a dashed line as opposed to a filled in solid line. If you do a colon, that can make it dotted. You can change the color as well. So if you do x comma y and then r, that gives you a red line instead. Then you can do the same thing for marker operators. So if you do x comma y and then you do a star, that converts everything, all the points to just stars. And you can mix and match these. So for example, if you want to do a solid red line with circle markers, let's say, that would be a dash for a solid line, red for the color, and O for circle markers. Or if you want a dashed blue line with star markers, that can be dash dash for dashed, B for blue, and then star for the markers. And that'll give you the graph here on the right. So I go ahead and show you here. So you can load the values in here, plot, and boom, you set a little plot. You can see here, it only plotted the last one. So you have the dash dash lines here, red line, green line. So let me just run this part here, red line. And then you can do the stars, as I mentioned. And then you can mix and match them as you see fit. Now, naturally, you probably don't know all the little ins and outs and all the different operators and parameters you can do for plot. So just like with every other function in MATLAB, just go to plot in the help function, and you'll get more than your fair share of examples and how-to guides on how to plot anything and everything in MATLAB. And then if you go back, you can see different types of plotting, function plots, line plots, different types of plots, and they all come with little tutorials on them. So let's say you don't want to plot in 2 dimensions, you want to plot in 3 dimensions. There's a plot three function, and it shows you how you can go about using it. No. So let's go ahead and do a little example here. So we're going to plot this more complicated function. For damped oscillation, you have e to negative at times this cosine of b times t. So how do we go about doing this? Well, we have an equation here, And we need to plot it for these values for time. So we need to create a vector that has all of these values for time that we're going to be evaluating this function at. So we can use the array creation tools I told you about, and we can create an array that goes from 0 to 20 seconds with a spacing of, let's say, 0.1. So this will give us an array from 0 to 20, spacing of 0.1. You can declare any parameters you want. So A and B are the only parameters in our equation. So we can just set them to, let's say, 0.1 and 1 for B. And then you just plot as normal. So plot t comma y, and then you add your labels. So x label function, give it, and give it seconds. Y label, m for millimeters. And then the title can just be damped oscillations, and then you apply your little legend. It really is that simple. And then now that we have this t value here, you can plug it in right here. Now, one important thing to note here is instead of using multiply, I use this dot multiply. So this is element by element operation. If I had not included this, I would have gotten an error, because just regular multiplication of vectors, because this is a vector and this is a vector, by default, MATLAB assumes you mean matrix multiplication. But what you really meant was, I want to take the first element of this, multiply by the first element of this, second element with the second element, and that's called element-wise operation. And that's why when I ran this code here, MATLAB says to perform element-wise multiplication, use dot star. So always be careful about that. So now plotting, putting on the grid, putting your labels, the titles, and the legend. And if I run this little section right here.
Wait.
Oh, yes. Somebody speak. So you can see a little plot window here. And you also have various tools you could use for your plotting window. So for example, here on the right, you can zoom in on certain parts. Right click to zoom out. So let's say I want to zoom in on this part right here and see what value it takes. You can do that. You can zoom out. You can click this data tips symbol right here. And this can grab values all along your curve. And if you didn't want to start coding things in here, you can naturally do X labels, Y labels, titles, and all that here. And if you wanted to, you could also do, where is it? The figure palettes. And start editing things inside your plot using this. So for example, if you wanted to draw a line here, so maybe you want to put an arrow right there, add a text box, this is cool, whatever you want to do. So naturally you can program this, or you can just do this after the fact in this figure window. You can also open up the plot browser and turn things off and on in your plot. You can also do a property editor, in which case now you can start editing information about your plot. So let's say we plotted from 0 to 20, but now I want to change this to the X limit from 0 to 10, let's say, and the graph will update. And let's say we want to go from Y instead of negative 0.8 to 1, we just want to look from 0. And now it just cuts things off. And you can see here, you can change the color of everything, background, whatever you'd like. And sadly, I don't have enough time to go over all the nitty-gritty details about this, but you can always look at the help and see how to work with all this. And naturally, all these little commands I just did also have a coding function for them in case you want to just code as well. Close that. Texting, relational and logical operators. So before I begin here, any questions? All right. So when you're creating something in MATLAB, you're generally writing some sort of script or program that does something for you that is tedious to do by yourself. And if you use a combination of relational and logical operators, you can make programs that you write think for themselves in a way and decide things for themselves based off some inputs. So you can do, for example, less than using less than symbol, greater than symbol, and so on and so forth. You You can do and, or not operators. So if this is true and this is true, code will continue. Is this value is less than that value but greater than this value, that do this, and so on and so forth. So that's why these are relational logical operators. So relational, you can use it to compare two values, so 1 less than 2. If you type this into MATLAB, it will say true and return a 1. If you do 10 is less than 0.1, this is false, so MATLAB will return a logical 0. And you can also use it to compare two vectors. So if you have two vectors of various numbers and you just want to compare them element by element, you can say, okay, is x equal to y? And if you do double equal, that will tell MATLAB this is a logical operation. So this is asking MATLAB, okay, is 1 equal to 0? Is 2 equal to 1? Is 3 equal to 2? Is 4 equal to 4? Is 5 equal to 1? And it'll check each of these out, and the only place it will match is where they're equal to each other. So this will be 0, 0, 0, 0, 1, 0, 0, 0, 0. And then you can mix and match these. So is 1 less than 2 and 2 less than 3? If both of these are true, then it turns true. If even one of these is false, it'll turn false. So here's an example of that. So 10 is less than 0.1. That's false. But this is an or symbol. So this is not true. But is this true? 2 less than 3. This is true. So all of this returns true. And I'll just show you here. So 1 less than 2, 1. 10 less than 0.1, 0. You can compare the two vectors. So compare some element by element. So you get 0, 0, 0, then 1. And now using this and symbol, so this only evaluates the true if both things on the left and right are also true. So 1 less than 2, this is true. 2 less than 3, also true, meaning all this is also true. 10 less than 0.1, false. 2 less than 3, true. This is an or symbol, so only one of these has to be true. So this evaluates the 1. Now here's how you can end up using it. You can use these logical operators in what are called if-else statements. So if-else statements lets your code sort of decide like a branches in a road of what it should do depending on the inputs you give it. So in this case, here's an example script I made for grades. So you give it a score, let's say 90, and you start off with if the variable name, and in this case, greater than or equal to 90. This logical operator will evaluate in MATLAB. If this is true, it's going to do what's inside of here. If it's false, it's going to go to the next line. And so, okay, else if. And then it's going to have another logical operator. And it's going to work its way down the tree until one of these ends up being true. If none of these are true, it's going to skip over to this else and then just do whatever the else says. So let's just see what this says. So the score is 90. So right now it's going to go into this loop and ask itself, is the score greater than or equal to 90? If this is true, it's going to display A. So if I ran this little part right here, you see A. If I change this to, let's say, 60, and I ran it again, it was D, because the score was 60. So MATLAB went into this loop and said, okay, is the score greater than or equal to 90? No, it is not. Next one, is the score greater than or equal to 80? No, it's not. Next one, score greater than or equal to 70? Nope. Score greater than or equal to 60? Yes, it is. So it goes over here, does display D, so it just shows this D into the command window, exits, and that's it. If it was done to these, so if I did like negative 3056 or whatever, you got a horrible score, and I ran this, it'll just say F, because none of these evaluated true, so it defaults to the else, which was just display F. Now, next thing is for loops. Any questions on the if-else?
Is there a case where you want to use switch?
So I think I did have, no. So switch is better if you're dealing not with numerical values, but dealing with character arrays. So switching between different options on a list, for example. So if the person inputted this letter or this word, do this option instead. So that's better. If else is better if you're dealing strictly with numerical data.
Sounds good.
All right. And next one, for loops. So the best way I can explain for loops is if I just give you an example. So let's say you want to add the numbers 1 to 100. How would you do it? So you could just go in MATLAB and type in x is equal to 1 plus 2 plus 3 plus 4 plus 5, and eventually you'll get to 100 and you'll get the right answer. But this is too slow. So what you do instead is you create a for loop that will do this addition for you automatically and just report back to you the final value. So here's how it works. The for loop says for, and then you give it some sort of dummy variable, and the dummy variable has a start value and an end value. And this loop will repeat for all the values that you give here, and then inside your code, you do something. So how would our code look like for this? So x is going to start off as a sum, essentially. So we start off at 0, and then in this case, I is our placeholder. And then I'm saying, okay, I is going to go from 1. And remember, this colon means it's going to create an array. So it's going to go from 1 to 100 with every single value in between. So 1, 2, 3, 4, 5. And this inside this do something, it's going to do x is equal to x plus II. So what does this mean? So every time it goes through this loop, it's going to take whatever the value of x is, it's going to add I to it, and then it's going to report back as the new I, as the new x, and then the loop is just going to repeat over and over and over again until you get to 100. And once you get to 100, it's going to exit out of the loop, and then you're going to get your answer. So let's go ahead and investigate how this works. So if you just do x is equal to 1, 2, 3, or 5, you get a value, 15, whatever. Now, as for our loop, you start off at x equals 0. Now, II is going to go from 1 to 100. So if I just evaluate this part right here, you can see 1 to 100. II is going to start off at 1. So if I force II to equal 1, and I see what happens here, x right now is 0. So x right now is 0. II is 1. So if we do x plus II, this is 1. And if I type x equals II, so now x is equal to 1. And now the loop would repeat again. But now II would equal to 2. And this exact same code would run again. Now x is equal to 3. Now II would equal to 3. And then this code would run again. And now x is equal to 6. And now II would equal to 4. And then you run this code again. And now x is equal to 10. And that's all this loop is doing. It's just repeating the exact same thing over and over again because it's tedious if you were to do it yourself. And if I ran this little code, and I do x is 5050. Easy enough. And you can change this to whatever you want. So you could do like times instead. Because it started off at 0, so it switched that. So if I make this 1, and you get a gigantic number because it's just multiplied all the numbers from 1 to 100. So you got a gigantic number. But that's how the basics of how a loop works. So any questions there? No? Actually, I want to get into. Oftentimes, when you're dealing in MATLAB, you want to import data into it. So usually this could be like text or Excel data. So if you want to do it, there are many ways you can do it in MATLAB. I generally like to use what's called MATLAB's built-in importing tool. So if you have text data as a text file or Excel, MATLAB can automatically import it if you right-click it and then you click import data. It'll bring up this dialog for you where you can actually select the data you want and then you can actually just import it. So here's our data, for example, this text file. And if I open it outside of MATLAB, you can see here in my text editor, this is time, temperature. So you have time in minutes, temperature in C. If I right-click this, import data, MATLAB automatically tries to separate this as best they can. Sometimes it's not good. In this case, delimited was the best way to separate this. So yes, time. And in this case, this should have been temp. And you just bring that there. So now, if you were to import this right now, MATLAB will import everything that's in this blue highlighted region. You can select what type of output do you want. Do you want it to be as a table, column vectors, matrix, however you want. So you can say as column vector, import, and it will import time, so the label, and it's a 9 by 1 matrix. So 9 rows, 1 column. And temp, the second column, has 9 rows, 1 column. Straightforward. And you can see here, you have your temp and your time. And now you can just go ahead and plot temp, time, temp, and plots the data for you. Straightforward. You can also use the read matrix command. So read matrix just takes in the data itself, and it'll just create the matrix that has the data in it in a single line. So no dealing with the import GUI tool. It also works with Excel data as well, so it's very versatile there. That you can parse the data, then you can just plot. So let me do that here. So I already showed you the temp data, and does the exact same thing, imports it directly. But you can also use this for Excel data. So if I do this, plots this Excel data, and then you can start parsing it, and then plot the result. And in this case, this is left ventricle pressure stored as one gigantic Excel spreadsheet. You can see pressure versus time. And that's how you would import Excel data. And the last thing I want to get into, or second last actually, is images. So if you have images that you want to load, you can do the im read and then the file name. By default, MATLAB accepts pretty much any image type. You have JPEG, PNG, TIFF, a bunch of others depending on your field. If you want to know which one specifically, you can do help im read to figure them all out. Then once you have your image loaded, you can use im show and then pass the image variable that you loaded, and this will show the image. And if you want to compare two images side by side, you can use image 1, image 2, and then tell it how you want to compare them. By default, MATLAB will try to put them on top of each other and let you compare their differences, sort of like a blend nature. But if you give this montage operator to it, it'll just compare them side by side. So then im read, I have this bird image right here. So if I open this outside of MATLAB, is this little bird image. Look at that, you can. So then im read. And because this is an image, it's a 3-dimensional matrix, so it outputs all these values for the color. And if you actually look at this image variable it made, im, which we saved, is 194 by 259 by 3, unit 8. And that means there's 194 rows, 259 columns, and 3 because there's red, green, and blue channels. And now if I do im show, here's your image. And you can do the same for any image you want, and then do im show pair. And in this case, it's comparing the Mona Lisa to this random cell image. And if the images are different sizes, it'll take whatever the largest image is and scale down the smaller image. And the last thing I want to get into is audio data. So just like how you can import images, you can also import audio. So audio files generally have the audio waveform as amplitude, and it also has a sampling frequency built into the file. So you can do audio read for both. And it'll output the audio and the sampling frequency if you do this designation. If you do not use this designation for the output, audio read will just sort of assume what the output should look like, and it's not going to sound right. So just to showcase it to you, if I do this, audio fs equals audio read of scatina band wave, that wave file, you can see here odd gives you the values for all the value for the entire audio signal. And in fact, you can do plot odd to actually see a visualization of the audio file. And the sampling frequency is in fs, so it looks like it's 22,050 hertz. And there's a function in MATLAB called sound that actually plays the sound for you. And I'm hoping I had set my share computer sound, so you should be able to hear this. If I just do sound odd, this sounds not quite right. Because if you don't specify what the sampling frequency is, then MATLAB sort of guesses it, and it usually guesses wrong. So in this case, it sounded weird, but if you do know what the sampling frequency is, and you tell MATLAB that's the sampling frequency, then when you run this sound command, yeah, and it works as expected. And that was the gist. Thank you. Any questions?
When are we going to go to the next Star Wars convention, fellas?
We'll see. We'll see. No conventions for now.
All right. Any questions, guys? Well, the learning doesn't stop there. This is only the beginning. So for those of us who started somewhere, all of us actually, the lesson continues. So make sure you get MATLAB and you practice this on yours by your own, because in 2 weeks we'll be having part 2 for you to learn new concepts. All right, guys. So that's all for now. Hope you learned something. Hope you enjoyed it. And stay safe, fellas.
No problem.